We're going to look at combining two or more transformations now. We're going to do that by looking at something that we've already met, but we didn't think of it as a transformation. So we've got the original graph here, y equals x squared, our standard parabola. And then over here, we have a quadratic which is written in completed the square form. So we know from our knowledge of that this one's going to have a turning point at 3, 4. So if we position that somewhere about here, again, standard parabola, something like that. Okay, so why have we written it like this? How does that help us understand combining transformations? Well, if we look at this, if we consider this original function as our f of x, then what is this transformed function in terms of f of x? Well, we've got to consider a few different things. First of all, what have we replaced our x with? Our x is still squared, but we've subtracted 3 from it. So we've replaced our x with an x minus 3. And then we've added 4. There was no add 4 here, we've added 4. So that's how we can think of that. So we can really view completing the square as a transformation of the standard quadratic. So now when we look at that, we can see, yes, f of x minus 3, it should move 3 to the right, plus 4, it should move 4 up. So we can think of combining transformations as just completing the square and a generalised version of that. Okay, so let's just have a look at how that's going to happen in a slightly more complex graph. So let's say that we have something which looks like that. Some sort of cubic, who knows? So we'll give ourselves some coordinates. Let's go for 2, 6. And then this one down here can be minus 1. And let's say that that is 3. Okay? This is our y equals f of x. And now I want to sketch y equals f of x minus 3 minus 4. Okay, so looking at that, we've got to think, how will the x values change? Well, let's look at this one. I'm going to add 3. Remember, we're solving an equation, so we do the opposite. Add 3, that will move to 2. And then I subtract 4 from the y values. So it was 3, it will move down to 1. Minus 1, sorry. Okay, just make sure you get everything in the correct quadrant. X is positive, y is negative. This one will move across to 5, down 4, so it will move to about here, and that will be 5, 2. As we said before, the shape should remain essentially the same. Something like that. Should be the same kind of shape, and we just apply this transformation one step at a time. That will work for any kind of graph. One final transformation, we'll just get rid of this transformed graph quickly. Okay. There we go. And we'll just have a look at a slightly different transformation. So let's this time go for a half of f of, let's say, x over 3. Okay? So again, we'll look at the x values first. We're solving an equation, so we do the opposite. We're going to multiply all of the x values by 3. This one will go to minus 3. And the y values will be halved. So that's going to go to minus 3, 3 over 2. This turning point will go to 6, 3. Again, basic shape doesn't change. Something like, oops, missed it. Something like this. Sorry, I've struggled to stretch it out enough. Let me just try that again. So we've got our turning point there. And then our second turning point will be somewhere over here. 6, 3. Okay. Should be the same shape, stretched out and squashed in. Okay. Label the point, don't worry too much about the scale once again.